Welcome to this third lesson on coasts, and in this lesson we'll be looking at how geological structure influences the development of coastal landscapes. So more specifically, you'll understand what the terms lithology, geology and morphology mean, and how these are linked to typical features that you see at the coast, such as cliffs and stumps. So there's some confusion over the terms lithology and geology generally. So the word geology really means the study of the rocks that make up the Earth's surface. So like geography means the study of the world, geology means the study of the rocks. However, we use that term geology interchangeably really to describe the general description of a rock type. So its composition, and this box on the right here gives a little summary if you want to pause the video and have a think about that. Lithology, the word lithology is more detailed than geology, and that really describes a rock type and the properties that go along with that. And there are three main rock types which we'll talk about in a moment, and but there are many varieties within that, and the properties associated with those rock types vary depending on how compacted the material is and other factors like that. Other things that are important about rocks is how they're structured, so whether they're structured in layers, whether they're folded, whether they're dipped, whether they're what angle the strike is at. These are all factors that are important. You don't need that too many details in a geography A level. However, if you are interested in geology at a later stage in your career, you might want to go and do some more research about this. You should remember from different parts of geography that relief means the height and shape of the land, the general unevenness at the surface of the earth, and morphology, the word morphology means shape, but in this case we're talking about the shape of the land. So when we're thinking about the shape of a coastline, what factors influence that shape? So remember that we've talked about the factors that influence the coast in previous two lessons, but remember we're focusing on the geology lithology today. So we've just got a quick summary there, top left, of the main factors that really influence what shape a coast is. So the lithology, which we're looking at today, how rocks are structured, which leads to varieties in relief or variation in relief, and variation in cliff profiles. Rock structure and type influence permeability of a rock, which is important in weathering and in erosion at the coast. And remember those other factors which we're not talking about in this lesson. So point 5 there, the other factors that influence the shape of the coast. So I suppose it's worth mentioning at this point that why do we care so much about coasts? Why is it on the syllabus, whereas other kind of areas of the world are not? Well, half the world's population live on the coast, and because we are an island in the UK, it's deemed an important part of geography studies because it's exceedingly long, the coastline of the UK, because we are an island. So if we're looking at this yellow box over here, if we put lithology, i.e. the rock type and characteristics of that rock, and structure together, i.e. how it's laid down, we see that we have these factors here in the yellow box, which we'll talk about in a bit more detail in a few slides time. So we're talking about whether rocks are laid in strata, in layers, which is generally a feature of sedimentary rocks. Bedding planes, as you can see on the image here, bedding planes are the angle at which the beds of how the beds are laid down. Joints are these sort of cracks in the rock, which are important obviously for water getting into the rocks. Folds, which we'll have a look at in a minute. Faults, dips, which is basically the angle the rock is at. The hardness of a rock, its permeability and its chemical composition. In other words, some rocks are more easily eroded by seawater, which is slightly acidic, and by rainwater due to their actual chemical composition. So if we're having a look at the lithology of the UK here, we can have a quick look at how varied our coastline is. So we've got, many parts of the UK have sand dunes, and here's Bamburgh in Northumberland. We've got the rocky coast of Cornwall, which many of you are probably familiar with. The Wash Estuary, which is on the east coast above the East Anglian coastline. It's a very flat area of land. And then we've got this picture here of this place in the Outer Hebrides on the Isle of Harris, which looks like a tropical beach, but is in actual fact in Scotland. So we have a large variety, and of course there are many more examples here. We've got salt marshes, we've got spits, tombolos, caves, many features which we'll go on to in later lessons. So if you want to kind of get a quick overview of how lithology is broken down, there are basically three main types of rocks. So we have igneous rocks here, and you might want to pause the video at this moment and make a quick note on what an igneous rock is. Igneous rocks are basically make up large parts of the continent, so large parts of the seafloor and the land, and many igneous rocks are exceedingly old because they have been basically formed in volcanoes and molten material a long time ago. The second main type of sedimentary rocks, where you get these typical strata and layers, more likely to form in low-lying areas. So we're interested in sandstone cliffs here, and compression compacts those layers down, so they and you can see the alternating bands of slightly different types of rock here in this picture. And if you're looking for fossils, fossils are usually found in sedimentary rock because they are laid down with the material that is laid down in layers in the past. And the final main type of rocks are metamorphic. If somebody goes through a metamorphic experience, they change. So metamorphic rocks are rocks that have changed, so they can be sedimentary or igneous rocks that have been subjected to pressure, heat, or fluids. And this changes their structure, and they are typically quite hard rocks. So we've got limestone, quartzite, which are metamorphosed from sandstone and gneiss. So you don't need to know too much more detail unless you're very interested in geology, but basically you can see a quick recap here of the rock cycle and how the rock cycle is an exceedingly slow cycle. We talked about this in carbon unit, but basically if we have weathering and erosion, we make sediments, and here's some examples of some sediments here, or some sedimentary type materials. And these rocks can be compacted over time by subsequent layers and get cemented, so they kind of change due to the pressure that's occurring upon them due to the layers above. And then we could end up with some nice sort of sedimentary rocks here, which can undergo a metamorphic process due to heat, perhaps if they are moved into closer to the centre of the earth, or if they are subject to large amounts of pressure from increasing amount of layers on top, and they might turn into these kind of more folded rocks. Some metamorphic rocks here are some examples underneath. Perhaps these rocks again are subducted and become melted, and then they might turn into igneous rocks. So this cycle just keeps going over a very long period of time. And we have some examples of different types of rocks here. The main ones that you need to sort of be aware of are what I'm having a look here down the list, what sandstones are and mudstones, what shale is, limestone, perhaps what slate is, what marble, and over here what granite is. They're the kind of main types of cliffs in the UK that you should be aware of. And here we have some pictures of some types of rocks if you want to kind of familiarise yourself with that slightly. It does help to some extent to know what they look like as a geographer, in case you do some coastal fieldwork, but also the examiner often uses the coast part of the course to use some data responsive photographs of coast. And if you are aware that you are looking at a sedimentary coast made of sandstone and you see some slumping, you'd be able to make that link between the type of rock. You'd be able to name the rock, which the examiner would really like, and you'd be able to comment on its properties and why that would lead to unstable cliff profiles. So when you're thinking about that rock type, whether it's igneous, sedimentary or metamorphic, that influences its permeability, and permeability means its ability to take water in. Rocks can be permeable, which allows water into them, and they can be also porous, which is slightly different. So porous means they have air spaces in there between the particles, which means that water gets in. Permeable means they might have cracks or faults in them, which allows water in. So it depends. So you cannot categorise the three main types of rocks based on whether they are permeable or impermeable, because again, it's more complicated than that. And apart from to say that igneous rocks are impermeable, sedimentary rocks can be permeable, porous, or impermeable depending on how compacted they are. And metamorphic rocks are, generally speaking, impermeable. But this does not mean they are not eroded. So be careful when you talk about rocks. All rocks are eroded if they come in contact with the sea. It's just the rate of erosion and how easy it is for the sea to erode, and that is a factor here. How rocks are structured is also important and influences cliff and beach profiles. So you don't need to know too much about this, but you can see here, bottom right, we've got rocks that where the strata appear to run into the sky or down into the earth. These are sedimentary rocks. They could not have been laid down like this. So these rocks must have undergone some form of metamorphosis, and they've been literally thrust up into the sky like that. They didn't form like that. They've undergone a process of metamorphosis in the past, and have ended up with their strata and their dip being in a very strange way. And here's another example of a rock that's undergone a metamorphic process. You can see that there might have originally been some layers in this rock over here. You can see this section of rock in the middle that looks like a big swirl has clearly been, over many millions of years, swirled into this pattern by perhaps heat or pressure. The dip of rocks here is a kind of two terms, which is sort of worth knowing, but we have dip and strike. So the dip angle of a rock is how the rocks are angled towards the sea. So you can see these rocks are basically very vertical. So they could be sloped a lot more shallowly. The dip angle could be a lot more shallow. The strike of a rock is to do with how it's a bit hard to explain. I'll come on to that in class. But if you're interested, again, you could go and look more of this up. So if we're thinking about different features at the coast, how might we try to start linking lithology, i.e. the rock type and its characteristics and the way it is structured? How might we think that these are linked to the development of coastal features? And you will see here Lulworth Cove, which you are familiar with from last lesson, and you should be able to have a think about lithology and structure here, about the Wealden beds and about the hard chalk layer at the back here. If you have forgotten all that, you might want to go back to the previous lesson and have a look at that when we look at concordant and discordant coastlines. What I want you to do here, though, is pause the video and make a little note 1 to 12 in your notes there, and attempt to name the features that you see here. I want you to attempt to name the features or kind of main characteristics of the pictures you see, and also suggest how the lithology, i.e. the rock type and its characteristics, and the way that the rock is laid down, have played a role in their formation. So you hopefully have managed to have a go at naming those 12 images and sort of describing the features and how they might have formed. Here's the sort of a very quick summary answer. You may not be familiar with number 11, a tombolo. So the number 11 here is a picture of a tombolo. This is a resistant rock here, and the tombolo stretches between the mainland, which is over here, and the island. That's what a tombolo is. But we'll come on to that when we look in future lessons at depositional features. So just check through these answers and pause the video here and have a look and see how what you have written is comparing to what is written here. So when we think about coastlines, we think about beaches. Cliffs are very common, obviously. Here we have the famous Seven Sisters chalk cliffs on the East Sussex coast, exceedingly famous chalk, relatively hard rock. And it's worth thinking about how cliff profiles, i.e. the shape of a cliff, or if you look at it sort of side on, how the shape of a cliff is directly affected by the lithology, i.e. the rock type and the characteristics of that rock and the way that rock is laid down. So if we look at picture 1 here, we see some uniform sort of layers of rock here, horizontal bedding planes, and these are, because the rocks are at sort of right angles to the coast, we basically have steep vertical cliffs. If you have dip here in picture 2 with cracks in the rocks, the dip and the cracks enable weathering and mass movement to occur and erosion at the base of the cliff. So these cliffs, generally speaking, are prone to more collapse than these vertical cliffs here. Here we have a very strong angle of dip in picture 3. So these rock slabs, these bedding planes, because they are different types of rock, can easily slide off the layer beneath, especially if water gets in from the top of the cliff and weathers that environment. So if water gets in from the top of the cliff, it acts like a lubricant between the layers. You've got the sea at the base of the cliff adding further erosional impacts, and the combination of the two allows those rock layers to slip into the sea. But you can see the cliff profile here is a lot more less vertical, a lot more, it's kind of dipping towards the land. Here we have the bedding planes are basically angled away from the sea, and we've again got fairly stable steep cliffs because there is less opportunity. If weathering occurred on the top of the cliff here, the land would not dip, it would not fall into the sea, it would kind of slide the other way. And however, you're still going to have cliff foot action going on here. What have we got here? On picture 5, we've got cliffs that basically, again, are dipping away, but because you've got a lot of joints at right angles to the bedding plane, you've got a lot of environments in which water from above, not from the sea, can get into that cliff. So these cliffs tend to produce sort of bits of rock that again will slide off the face of the cliff rather than slide off the kind of layers of the bedding planes. Rock falls here, this kind of cliff profile here, rock falls are just a form of mass movement where large amounts of material move down the cliff suddenly. It's a kind of explosive movement. So when you have hard cliffs with horizontal bedding planes, blocks basically get eventually weathered and the fall to the cliff base. So we look at this in more detail in a later lesson. So we've got just to sort of remind you that cliffs are subject to marine processes from the base of the cliff, but they're also subject to subaerial processes, which we'll come on to in a later lesson, which basically means mass movement and weathering, which are processes from the top of the cliff. So we have these two factors that affect cliff profiles, which are also directly linked to the lithology and the structure of the rock. So all these factors combined basically influence the rates of erosion at a cliff. So we've got obviously the rock type and the way its characteristics affect the rate of erosion, and we've got weathering at the mass movement process of weathering at the top of a cliff, whether we've got high energy waves, whether there's a beach. If we've got a beach at the foot of the cliff, it protects the cliffs from erosion. Whether we've got rising sea levels, obviously rising sea levels will increase the rate of erosion, and whether we've got some human interference there with coastal management. These will all affect rates of erosion at the cliff. So you can see this picture on the right here, the Holderness coast, which you may be familiar with from GCSE geography. And the Holderness coast is one of the fastest eroding coastlines in Europe. And you can see that this is because it's made up of glacial till here, so its rate of erosion between 1 and 10 metres per year, depending on a number of factors such as whether the coast is managed, whether there's been a very stormy winter, and things like that. So the Holderness coast is very quickly eroded. It's to do with its rock types, a glacial till. is an unconsolidated, which means it is not compacted together. It's very loose material. Glacial till, what does that mean? It's material left behind from retreating glaciers in the last ice age. So it's very soft material. The glacier has done the work of breaking it down. So it's very soft, easily eroding material. If you look at these different types of rock and their erosion rates in different parts of the UK, we have sandstone cliffs of Devon. Again, fairly easily eroded to some extent because sandstone is a sedimentary rock. And then we have the limestone cliffs of Dorset. We've got other rocks in Dorset, obviously. We're going to go on to look at a case study of Dorset in the next lesson, looking at the different types of rocks and main features of the Jurassic coastline in Dorset. But you'll see that basically this rock is a lot harder to erode, so it has much slower rates of recession or slower rates of erosion. And then granite cliffs in Cornwall, perhaps only 1 millimetre a year, so you wait a long time to see those cliffs change. So at the end of this lesson, which is fairly brief introduction to geology, what should you know? So you should realise that geology, what it is, and lithology affect the shape of the coast and its relief, and you should be aware that different rock types have properties which affect the shape and features of things at the coast. So not just the rock type, but how it's also laid down is important. Its structure, whether it's got joints, what angle the dip is, whether there are faults, whether it's been folded by metamorphic processes. These are all important influences on the shape of the coast. And this is also linked to erosion rates at the coast and also to different cliff profiles. So you should be able to talk about a vertical cliff profile, shallow dips or dips angling towards the coast or away from the coast, and how these lead to differing rates of erosion. You should be able to talk about the direct relationship between lithology, rock structure and cliff profiles. And you should keep in mind, although we haven't talked about it yet, you should keep in mind that while geology and lithology are exceedingly important in shaping cliff and beach profiles, that other factors aside from these things affect the morphology of the coast.